My name is Kashyap Badrevu, and my project title is Sentiment Analysis to Figure Out Deceptive Reviews on Hotel Dataset. I will explain what the deceptive means when I go through the dataset. My name is Kashyap Badrevu, and my ID is 18771243. So the goal of this project is to classify the user sentiments on hotel reviews as negative or positive by eliminating deceptive reviews. I use supervised machine learning for this. And I got the dataset from Kaggle, and this is the link for the corpus. So the data I got is in the CSV format, and it had about 1600 records, and it had reviews for 20 hotels from Chicago. Out of the 1600, 400 were truthful positive reviews, 400 were deceptive positive reviews, and then 400 were truthful negative reviews, and finally 400 deceptive negative reviews. So what this deceptive review means is that it's a fake review where you can't authenticate the reviewer. And truthful means obviously it's a genuine review. And positive review is like user is appreciating the hotel, negative review is user didn't like the services, etc. Now this data set has 20 reviews for each of those 20 hotels. So these are the fields of the data set. So deceptive, as I have explained before, and this column only has two values, either truthful or deceptive, and then the name of the hotel and polarity. And now polarity instead of scores, the dataset only has two values, positive or negative. So this helps us determine the sentiments of the users. And then we have the source where the review was taken from, and the text, which is the actual review. Initially, I did some data cleaning. So to do that, first I did tokenization. So for tokenization, I used the tweet tokenizer function in the analyticator tokenized package. So essentially what it does is it breaks the review sentences into tokens. And then after breaking them into tokens, I did some normalization, which is like stemming, which means chopping of the word, chopping of the affixes of the word, and then converting the capital letters to lower case, etc. So I have written the tokenize and stem function, which can be called from this count vectorizer. And then I did the feature extraction. So I used the bag of words model, and to implement it, I used the feature extraction module from scikit-learn to create the bag of words features. That feature is what means it's an attribute of the component, which means here it is the review, and it has different features, which are the words. So that essentially what I'm doing is I'm converting the review into an n-dimensional vector, where n is the number of terms or words for that particular review. And each review is represented in this manner. So, and then I use the F1 score for evaluating different models and compare them. And while training the SVM model, I also did grid search to find good hyperparameters. And then I wrote a pipeline function which ignores the features that are not written from the grid search, from these validation folds when I'm building that model. So this is the code for the pipeline function. So first, initially, through the supervised machine learning, I used naive Bayes approach, and I found that only 86% of the reviews were classified correctly. And then I tried random forest approach. I did the same pre-processing for this as well, and I used the number of trees as 100, which I think is reasonable. And for this, the F1 score came out to be better than naive Bayes, and the score is 0.921, etc. And then finally, I tried the support vector machine, the SVM model. So this provided me with better results initially, but as I said before, to improve on the results, I found that this is better than the previous approaches. So I decided to select this one and then did the grid search on this model. So it basically does an exhaustive search over the specified parameter values that I have specified to extract the best parameters, which covers a lot of variance. And after doing that, my F1 score has improved significantly, and it came out to be 0.952. And once I got that, then I used different kernel tricks and then compared those results. So first I trained with RBF, and then I used linear kernel trick, and I found that the linear kernel trick did far better than the RBF. You can see the results in here. And then this is the these are the accuracy scores for SVM after the grid search, and these are the final results. So this is a word cloud of positive words, and the larger the word, the higher the frequency. That word in the reviews given by the users, and it's the same for the negative words as well. And then this is the receiver operator characteristic curve, ROC curve, for the machine learning model that I have finally selected, which is SVM. So the x-axis is false positive rate, and the y-axis is true positive rate, and the curve goes like this for the SVM model. And this is the final accuracy of the SVM model. And this is a graph. This is a plot of training score against cross-validation score. And even this I did only for SVM model, because that's the one I finally settled down. So that's it. Thank you.